routing context. Internet virtual router. Okay everyone, in this video we're going to take a look at routing context, or better known as virtual routers. So this particular feature on the Palo Alto will allow you to separate routing instances. In a better term, you can have interfaces allocated to a router, and quote router because it's still a router. The only difference here is virtually created on the Palo Alto. So you have two interfaces. One is sitting on the outside side of your network, in this case the internet, and the other one is sitting on the core side or the inside. And then you allocate that side of your network into router 1. And then you create virtual router 1. You assign those two interfaces together, and then those are members of that particular router. It's like, imagine yourself as you have a router appliance or a hardware router, and you're plugging those two ports in that particular router, and then you create your route statements. Either you put static routes or you turn on dynamic routing such as OSPF or BGP, and you configure your routing statements. Benefit of doing this: 1, you separate routing instances. You have an easier way to troubleshoot routing because you're actually segmenting traffic. In Palo Alto, if you have an issue on the internet side, you don't need to look at any other place, the particular firewall, but the router on the internet side if it's related to a routing issue. Second, security. So your servers, most definitely, they'll route the same way that the clients are routing on the environment, but you don't want the clients to have direct access to the servers. You want the clients to go through the Palo Alto, and if you can take a look at the picture that I'm showing here on the slide, I basically have two interfaces. I have one interface, and my core switch is plugged in into port 2 on the Palo Alto, and this port 2 belongs to the router 1, which is the internet router. Port 3 belongs to router 2. On my core switch, I have a routing statement or a static route saying if I want to go to the internet, please send all traffic to the IP that is assigned on interface Ethernet 2. So now everyone basically will hop onto the Palo Alto and hit this router, and from there you go straight to the internet. If the clients, they need to reach the servers, they'll need to pass through the Palo Alto firewall in order to get to the servers. So what's the purpose of that? This is when we can apply security policies, because I'm going to have two interfaces. The interface between my core and my server router, I can call it router 2 or the server router. It's sitting on the untrusted. So anything that arrives from this particular interface or the untrusted needs to have a security policy that will allow that to communicate to the trusted. And you see what's the benefit of having separate routing instances. You can still do it in this one, right? Do you want complexity as you keep adding networks and networks onto your Palo Alto? I don't think so. I will not like a complex environment. If I have those features available, I might as well use them. So this is the real reason you want to have different routing instances, because you apply particular settings to each one, and if you need to troubleshoot or if you need to make changes, you're not impacting the whole environment in one single change. You're only impacting what's only being used on this particular routing instance or this one. Another thing, I can have another core switch here, and the clients are basically separated via my Palo Alto in order to hit the servers. This is also what is known on the common Cisco iOS and XOS world as VRF, so virtual routing forwarding instances. So you create a VRF, you add the interfaces onto it, and you separate that traffic. If you want VRFs or virtual routing instances to talk between each other, in the Cisco world, you need to create a route leaking. In this case, you create an ACL, you call a couple of subnets, and you perform route leaking, and that's how you can basically leak traffic between the two. We're not obviously discussing this on our training session, but we're discussing a very similar approach to segment that type of traffic. And then also you limit your routing table to be a smaller one, because also you don't want to have a long list of subnets and routing statements or routing adjacencies all belonging to one particular router. You want to make sure that you have that separated, and this is a reason why you want to adopt virtual routers. So you will see now on my presentation, I will be configuring this environment. I will configure the inside side, going to the outside, and we'll have a interface configured and connected to port 2. We're gonna have also another interface from my core connected to port 3, and they're basically going to two different routers. Router 1 sends all traffic to the internet. Router 2 sends all traffic to the server side. So you now know that your servers are completely isolated via the Palo Alto. So any client, any guest on your network, any end device will need to hop on the Palo Alto, head the server router, head the security policy in order to get allowed and go to the server side. So let's begin. Let's take a look at that, and we'll go from there. Okay, let's go ahead and configure our first router, and we're gonna configure virtual router 1, and this will provide internet service to our internal users. So let's go ahead and begin with this one. In order to configure a virtual router, we're gonna go into network, we're gonna click virtual routers, and we're gonna click add. Once inside the virtual router window, we're gonna select the name. In this case, we're going to configure that virtual router 1. We're going to call it VRTR 1-INET, which is our internet router. And then let me give you a quick walkthrough of what the options are. In general, we have the session where we assign the interfaces that are going to belong to this particular virtual router. In this case, if you have two interfaces, one facing the outside, one facing the inside, you're going to be allocating them here. Equal cost multipathing. If your environment needs to have equal cost multipathing, you can enable here, add the two interfaces, and enable ECMP. We're going to go here into static routes, and this is where you add static routes onto this particular virtual router instance. If you want to add a particular route pointing to an interface, you can add it here. So if we click add, in this case, say I want to go to the outside, and this is my default route, or the quad 0 route, and basically select 000, and then we can point it to a specific interface that belongs to the virtual router, and this is, we're going to be allocating the interfaces in a bit. Once we allocate them, you should be able to select it from here. Next hop, then we're going to tell, okay, in order for us to get to this destination, this is my next hop on the interface that I'm selecting, and that will send the traffic to that destination, and then from there, the forwarding router will take care of it. Distance, depends on if you have multiple static routes, and each one will have a preferred distance over the other. So we're going to be creating a preferred route versus the other. You can tweak this here. A metric, you can set metrics per route, and again, it's a way to do some routing customizations or do some sort of basic routing engineering in this case. Route table, in this case, is a unicast route table. You can configure a multicast. If you are routing multicast on the Palo Alto, you allocate this particular route as a multicast route. Bidirectional forwarding detection, if you want to enable BFD on the interfaces, so you have a faster reconvergence in case the interface bounces, you have a faster way to send that hello versus the normal second interval that it's by default. So you can enable BFD here. Monitoring, if you want to monitor the path and then select, hey, this is the condition that I want to have in case this path path A went down, I want to switch to path B. You can configure it, and then you need to have path monitoring enabled for this to work. So let's go ahead and continue. If you want to do redistribution, either static into dynamic, you can do it from here. It has the options for both IPv4 and IPv6. Enabling RIP, very old routing protocol. I will be surprised if there's still internal environments using RIP, but I've seen it all. So I most certainly will be able to see one. OSPF, same thing, very common. You configure OSPF. We're going to be configuring that on the server router. So I'm going to show you how to configure OSPF. You have version 2 as well as version 3. So we can select either one of them, what your environment is currently running. BGP, you have the option of going full-blown BGP, and again, you select enable, and then you add the properties, and you're good to go. Multicasting, you can configure a local RP or rendezvous point for specific multicast. SSM, having interfaces participating in multicast. All this is available via the virtual router. So every time that you create a virtual routing instance, it's a completely independent setting from the other virtual router that you already have. So every time that you create a virtual router, it's like creating a completely different virtual appliance with individual settings. So let's go ahead and create the first one, and this is virtual router 1 INET. And in general, we're not going to type anything because we haven't allocated any interfaces yet. So let's go ahead and just create the virtual router. And now we mentioned in our slide that we want to allocate interface Ethernet 02 to be the interface, inbound interface for my internal clients. So let's go ahead and select interface 2 and allocate that to the router that we just created. Select interface 2. Very important, let's select this to be a layer 3 interface so we can add that to the virtual router. And then this is here where we select the new virtual router that we just created. So by doing that, the interface has been enabled in the particular routing instance. And then security zone, and we're gonna say this is our inside. IPv4, let's configure an IP address, and this IP address will be .1 on the Palo Alto side. On my core side, I already have this subnet with .2, so we're going to configure that one on the Palo Alto. Let's type it in real quick. By the way, it's going to be a /30. Okay, and then advanced, let me make sure that we have ping. Okay, so we have the first one, and we're going to click commit, and we should have that routing instance or virtual router allocated with interface Ethernet port 2. Once we do that, we're going to do now, particularly I have an interface sitting on the outside, and I'm just going to allow that to get a DHCP address because that interface sits on a DHCP enabled network. And we're going to add that again. This is our outside interface, and you can type a comment here, okay? And then let's make this the outside, belonging to the same router, IPv4, and we're just going to make it a DHCP client because just one IP allocated to it. Make sure that we can ping it, and okay, we should be good on there. Let's hit commit. Now we have 10.100.255.1. I have a core switch that I already configured with .2. So let's take a look at that. Okay, so that port, it's .2. Take a look real quick. By the way, I typed 100. This will be .200. Just let me correct this real quick here. That will belong to the inside to outside, and then I have 100, which will go to the server side. Press commit, and we should be good to do a testing to know that we're reaching the Palo Alto from the core switch. Okay, so I'm here on my core switch, so you can see port 5 goes to port 2. Port 2 on the Palo Alto is .1, port 5 is .2, so let's take a look and see if we can ping it to know that we're doing end-to-end reachability. So this is my local, and let's see if resolves. There you go. So I'm able to ping it, so that tells me that I got end-to-end communication between those two interfaces. So let's do some magic here. Let's now make that router talk to the outside. I have a dedicated outside interface, and I just want to make sure that I can route to the outside. Okay, in order for me to route, I need to do a quick NAT, and we're going to discuss NAT on our next video. For this purpose, I'm just going to configure it real quick, and we'll go from there. So let me go here quick, a NAT, we're going to do a source NAT. We're going to say outside, and it's coming from my source zone, which will be the outside, the inside, any source address, and we're going to do a dynamic IP import. I'm going to select our interface, and this is my outgoing interface, and I'm just going to use the interface IP. And as a matter of fact, just applied the NAT. However, I don't have a security policy. So even though I have both interfaces, the outside and the inside, on the router, they're not going to be able to talk because I don't have a policy allowing those two interfaces, the inside and the outside, to talk. And we can make sure that's actually accurate. So if I ping the outside, let's ping 8.8.8, I cannot go anywhere. Make sure that I got the route. I do have the default route, which points to that one, but I can definitely not ping. So let's fix that by putting a simple security policy in place, and we should be good to go. Go at it real quick. Configure a quick security policy. Let's call this inside to internet. And then source. It's going to be inside going to the outside. And we'll just leave this on default. We're going to allow. Okay. And I'm just going to press commit. And now we should be able to have communication to the outside. Okay, let's go ahead and give it a shot. See if we're lucky. Yes, we are. So, very simple. We did our first virtual router, and this is router 1. This allows our core switch to reach the outside between the inside and the outside interfaces. So we created those interfaces, we allocate them into the zones, inside zone and outside zone. We added those interfaces onto the virtual router, and then I basically created a NAT rule and a security policy, and boom, I have reachability to the outside. Let's go ahead and do the second router. This one will allow my core, this is my inside core switch, to hit the servers, which are on a completely separate network. Okay, we just finished configuring the INET router. In the next video, we're gonna go ahead and configure the server router.